Let's take a look at what's required to integrate Snowpark with Amazon's Sagemaker. Here I am on the Amazon console home, and what I'm going to do is go over to Amazon Sagemaker, and from here I'm going to go ahead into Sagemaker Studio and select Open Studio. And while that loads, you can see that we'll get to a Jupyter Lab session here in just a moment. Typical activity logo spinning on screen for us. And in just a moment, we should wind up with a Jupyter notebook. I'm going to go ahead and close this one and start fresh. So from here, what I want to do is take advantage of the quick actions. I'll go ahead and open the launcher. And before I create any notebooks, I first want to confirm the image and kernel. Definitely want to be using Python 3, but in my environment, I want to change the image that'll be selected for this session. I'm going to go over here to change environment. Snowpark currently requires Python 3.8. So what I want to do in Sagemaker Studio here is click on the drop down under image and locate an image that is that has its foundation in Python 3.8. So it looks like Data Science 2.0 is such an image. We'll go ahead and select that. And everything else looks fine. There are certain activities that you'll see me do in a moment that could be incorporated into a startup script to save some time, but we'll go through the manual steps to show you what's required. Go ahead and select that, and from here I'll create a notebook. Now that's going to take a little bit of time for the compute to start up and provision on AWS. So I'll cut the video, let that provision, and then come back and continue the demonstration. All right, our compute is now provisioned and we can get started. So let's have a look at our list of files here. I'm going to go ahead and check out our folders. Got a few notebooks that I've worked with in the past. I've also got a creds.json file here that holds my authentication credentials for Snowflake. But first step, we need to get the Snowpark Python libraries installed on this compute instance. Now, these are the things that we can incorporate into a startup script to save us from having to include them in the notebook, but I thought it would be good for you to see what's required here in the demonstration. So as I think you might be familiar, starting with the % gives us the opportunity to run operating system specific commands. And in this case, I'm going to do a pip install for the Python, the Snowflake connector. With pandas support. Okay, and the next thing I'm going to install right after that is the Snowpark library. All right, so we'll go ahead and add a few cells here for things we'll do later on. All right, and so I'll go ahead and execute this cell. All right, and you'll see that go through and install the requisite modules for the Snowflake connector and Snowpark. All right, that's now complete, and at this point we can begin to go to work. But first, I want to import a couple of Python modules for some specific purposes. So let's first import OS, and we're also going to import built-ins, and you'll see why in a moment. For OS, I want to be able to understand what my current working directory is here on this Amazon provisioned compute. So we'll do os dot get current working directory, and then I want to use the open function from, or the open method from the built-ins library to read my credential file. And when I do that, I want to say all right, so let's go ahead and execute these cells. All right, and our current working directory we can see is root/Snowflake, which is good. That is an indicator that we're in the same directory that holds our creds.json file. So we should have no problem executing this next cell as it exists. If we happen to be in another directory, then what we would have to do is to specify the full path to the creds.json file, depending upon the results of this command. But we'll go ahead and run that. Oh, and we have an error. So let's see. Oh, I did not import the JSON library. Go ahead and correct that. Run this. And that looks much better. Let's verify that we read that creds file correctly by showing the user attribute. Go ahead and run that cell. And so rcode_demo is the username that I want to utilize as I log into Snowflake. At this point, we're ready to go ahead and create our session variable. Doing so is as simple as creating a variable and then assigning to that variable the results of a call to session. And we do that like so. We'll pass my creds to configs, and that is all that's required to establish our Snowpark session. Go ahead and run this cell. And what did I do wrong? Oh, I never imported the session module. So let's correct that. I'm going to go ahead and, I'd normally do that in this section here, but I'm going to go ahead and create another cell to do that. All right, go ahead and run this cell. Then create my session. And that looks much better. Now, with that session, I can now begin to issue queries to Snowflake and all sorts of things, enabling me to take advantage of the scalable compute and intelligent infrastructure provided by Snowflake. So to start out, let's, I don't know, let's take a look at the tables to which we have access by default. So the way we'll do that is we'll go ahead and create a data frame by calling a method on my session variable. So we'll say good old Snowflake show tables command, and then we will show the contents of that data frame. Go ahead and run this cell. Not MyDF, but MDF. All right, and those are the tables to which I have access by default. And we can continue this theme. I'll go ahead and query one of these tables. Let's see. Go ahead and copy our Uber Eats table name here, paste it in the query, and then we will show the contents of the data frame. All right, so there are the contents of my Uber Eats table as it resides on Snowflake. Let's say I wanted to, for whatever reason, get this data into a pandas data frame resident on the AWS compute upon which I'm operating. Just to reiterate and clarify, as it stands, we have taken advantage of the Snowpark API to provide us with data frames that are a window into the data on Snowflake. In other words, we've not moved that data out of the data warehouse and into local compute just yet. We're simply using a window into the data on Snowflake, taking advantage of the methods available to us via the Snowpark API. In the event that we needed to bring that data locally, we would do so in this way. So we'll say, create a variable for a local data frame, call it LDF, and I will call on my df_ue. I'll call the two pandas method, and then get the information on the local data frame. Go ahead and run this cell. And we've now taken data out of Snowflake, or copied data from Snowflake is probably a better way to say that, brought that data into a local data frame running or that exists on the compute instance provided by AWS, and now we have the structure of that local data frame. And obviously we can show the contents of the data frame by issuing some familiar, by taking advantage of some familiar pandas methods, such as the head method, and we'll show the first 20 records here. All right, so pretty straightforward, right? What we've shown in this video is how we can take advantage of compute provided by AWS using Amazon SageMaker Studio, incorporating the Snowflake Snowpark library or API into SageMaker Studio, and using SageMaker Studio to manipulate, view, calculate, copy data provided by Snowflake. Hope you found this useful, and you'll see me in the next one.